Now, let's have a look at transforming parabolas. We first had a look at this last year about this time in grade 10. So this is what we call the turning point formula of a quadratic. So it's in this general form of y equals a outside of x minus h plus k. So when we look at the setup here, we can see that our a value from our original one is 2. That's the dilation factor. That controls how fat or skinny the graph is. So if I had my original graph as y equals x squared, this a value here would make it get more skinny. Now, if I had an a value that was less than 1, it would make the graph get more fat. The textbook talks about dilation to the y-axis, so we'll make it bigger than 1, we'll make it get closer to the y-axis, less than 1 will make it get away from the x-axis. If it was negative, it would flip it upside down. So there's the a value, dilation. Now, in here, we want the contents of the bracket to be 0, so our h value is going to be, in our case, so whatever would make x minus 3 equal to 0, that's when x is equal to 3, so that's our h value. It's the negative of what's in here. So if I'm taking 3 away, my h value is positive 3. Anything inside the brackets shifts the graph left and right. So this minus 3 in here, h value of positive 3, shifts the graph 3 units to the right. So it'll be shifted over. And then lastly, the k value on the end, in this case negative 8, obviously our polynomial, the number on the end will just move the graph up or down. So this one's going to move the graph down 8 places. So given that, we are able to state that the turning point of this particular function is going to be 3, negative 8. So we're able to use this information, plus where it cuts the x-axis and the y-axis, and do a reasonably accurate graph of it. Give me a moment, I'm going to clear this off and then we'll finish graphing this one. Now, let's have a look at these two scenarios. I've now already used this in its turning point form to read off that the turning point of this particular quadratic is at 3, negative 8. So I'm now going to find where it cuts the y-axis. So where it cuts the y-axis is when x is equal to 0. So therefore my y is going to be equal to 2 outside of 0 minus 3 squared, take away 8. And just evaluate that. So this is going to have a y-intercept at positive 10. So if I now do the opposite, make y equals 0, I'll find the roots of the equation where it cuts the x-axis. Now, I'm able to show that it cuts the x-axis at positive 5 and positive 1. If I put that information together now, I can go ahead and graph that. So I'm looking for a turning point at 3, negative 8. And if I cut the y-axis at positive 10, up here somewhere, and looking for roots at 5 and 1. 5, that's 1, 5, join that up, voila. You have a pretty good sketch of what this function looks like when it's in turning point form. In a moment, I'm going to rub this off and then give you one more question where we, instead of starting with the function and drawing the graph, we're going to go backwards. I'm going to give you the graph and work out the function. Okay, let's have a look at this one. We've now got the quadratic. Let's now work backwards from the graph to the actual function. So, once again, we're going to use the turning point formula. Now, h and k are the coordinates of our turning point. So, the x value is 4, so that means, and then y value is 2, so 2. So therefore I've now got the h and k values thrown in here. All I need now is the a value. So if we have one more point of information, we're actually able to work that out. The point of information we're given here is the fact that it goes through the origin 0, 0. So if we substitute 0, 0 into here, we can work out a. So my y coordinate is 0, a outside of x coordinate is also 0, Now, if I evaluate that, I'll work out A. Now, by doing the calculation, I'm able to show that A has a value of negative 1/8, which makes sense. A being negative flips the curve upside down. So I can therefore say that my final function is negative 1/8 x minus 4 squared plus 2. So there are the two types of problems that you're going to come across with turning point form of a quadratic. Good luck, I'll see you in class with them.